All right, brand new chapter. We kind of started this on Friday. We gave a little introduction. Let's review that briefly. Okay, the introduction, classifying quadrilaterals. What's one of the main quadrilaterals that we talk about a lot? It starts with a P. Parallelogram, good. All right, what's parallelogram? I'm just going to do a quick little hand-drawn sketch. Looks like this. Okay, parallelogram looks like this. Now, it could look like some other things as well. We'll talk about that in a second. But what do I know about a parallelogram? I know that the opposite sides are what to each other? Parallel. That's why the word parallelogram. Okay, the opposite sides are parallel. So these top and bottom are parallel, and these ones off to the side, they are parallel to each other. Okay, so that's a parallelogram. Now, we talked about three specific types of parallelograms. So quadrilateral is like the real big, what do I call it? Just general, very general word for a four-sided figure. But then we get more specific as we go down. So that's the most general word for a four-sided figure, quadrilateral. Then you get a little bit more specific, and that's a parallelogram. And then you go down from there. So I'll do this. I'll make a little quadrilateral. All right, so it goes quadrilateral, and then and that's very, very general. It's any four-sided figure, okay? That's a quadrilateral. But then you get a little more specific. A parallelogram is a quadrilateral, but it's a specific type of quadrilateral. It's one that has both pairs of opposite sides parallel to each other, all right? So that's a parallelogram. And then you can get a little bit more specific. In fact, these kind of are like on the same level. So you had, the first one was a rectangle, all right? And then next to it, we'll do it like this. Next to it was a rhombus. And then the next one was a square. I'm putting that all on the same line. Is that all right? It's kind of like a hierarchy. You ever hear that word? All right. So a hierarchy, like the king is in control, like not hopefully in the United States, even though some people are calling Trump a king. But anyway, you got a king, then you got a queen, then you got the people underneath, right? You got a president, you got a vice president, then you got the whatever the thing is, Secretary of State, I think would be next, that kind of thing. That's what we're doing here. Quadrilateral, then parallelogram. These kind of all have a little bit to do with each other. This is a specific type of parallelogram, okay? And what do we know about a rectangle? Well, we know what a rectangle looks like, but a rectangle is a parallelogram, okay? It's in this hierarchy of quadrilaterals. So it is a parallelogram, but it's a parallelogram with what? 4 right angles. Well, every quadrilateral has 4 sides, but a rectangle specifically has 4 what? Right angles, okay? What's a rhombus? A rhombus is also a parallelogram. All right, so it looks like a parallelogram. All right, but what's specifically true about a rhombus? It's got 4 equal sides. Good. So all 4 of these sides are equal to each other. All right. Remember, it's still a parallelogram, but it's a specific type of parallelogram. Now, if you put these together, right, if you put those together, I don't think I said this in this class. In the other class, I said, okay, let's say they got married and had a kid. What would a rectangle and a rhombus be if you combine them together? It would be a square. Okay. Why? Because a square has 4 right angles and all 4 sides are equal to each other. So what's true about this one and this one together, if you put them together, you get a what? You get a square. Okay? Everybody with me on that? All right, let's review. Oops. We did this just the other day. All right. So actually, this next thing we're going to do is not a parallelogram. So this kind of goes like off to the side. All right, so it's not a parallelogram, but it is a quadrilateral. And what did we say it was? It was a kite. And I'm going to try to draw a kite by hand. All right, it's close enough. Not exactly, but it's close enough. What do we know about a kite? Well, first of all, a kite is not a what? A parallelogram. Okay, I'll just put the symbol for parallelogram. Is that all right? So a kite is not a parallelogram because both pairs of opposite sides are not parallel to each other, but it is a quadrilateral. So this fits under the quadrilateral category, I guess. All right. Well, what do we know? We know that it has two pairs of equal consecutive sides, okay? And the sides that are opposite each other are not equal to each other. All right, so that's what we know about a kite. So these two sides would be equal and these two sides would be equal. We have more that we know about a kite, but this is just by definition, okay? All these are just by definition. We're going to learn some more specific things about this, a rectangle, a rhombus, a square, a kite, and that kind of thing. We're just not going to learn it right now. And I don't even think we're going to learn this lesson. I think it's another lesson. Let me just double check. Yeah, it's another lesson that we are going to learn some specific things about, more specific about a rectangle, rhombus, and square. So we're not done with this. Okay, we're not done with these things. We're not done with a kite. We're going to learn more about it, but we're going to learn more about it in another lesson. All right? Everybody got it? Okay, so the one thing, it's because I put it on the back of my notes. See, I put all the stuff that we did Friday here. I don't think we had time to get to it anyway, but we do have a, how many was that? We did 1, 2, 3, 4, 5, a sixth one, right? So we did parallelogram, that's 1, 2, 3, 4, 5, kite, and we have a sixth one that we did not do on Friday. And I think I mentioned it earlier before I started teaching. Do you remember what I said? Starts with a T. Anybody remember? That's all right, no big deal. I'll tell you now. It's a trapezoid. Remember me saying that? Did you? Okay, so it's a trapezoid. What in the world is a trapezoid? Well, a trapezoid is not, okay, this is not really a definition, but I'm going to put it on here anyway. It's not a, what do we say about the kite? It's not a parallelogram, okay? But it is a what? It's got four sides, so it's got to be a what? It's quadrilateral, okay? Again, a quadrilateral just means what? It's just a general four-sided figure. It's all it is. We good? All right. So it's not a parallelogram. But what it is, it's a quadrilateral. I'll just shorten quadrilateral with quad. Is that all right? With exactly one pair of parallel sides. Of parallel sides. It says exactly. Now, how many does a parallelogram have? How many pairs of parallel sides does a parallelogram have? It's got two. But a trapezoid only has what? One pair of parallel sides. So let's draw it. You can draw it a bunch of different ways. Go about right there. So that right there looks like a trapezoid. How do I know it's a trapezoid for real? It's got four sides, so it's a quadrilateral for sure. It looks like this top one and this bottom one are what to each other? Parallel to each other. But do I know just by that picture? No. I need the arrows, right. So now what can you say about this thing? Okay, they're parallel, so the four-sided figure, the quadrilateral, is a what? It's a trapezoid. You're welcome. All right, so this thing right here is a trapezoid. Why? Because it has exactly one pair. That means this side right here and this side right here are not what? Parallel. That's right, because it only has one pair of parallel sides. You got it? A parallelogram, I didn't draw very well. I'll tell you what. I'll just sketch it. A parallelogram has what? Two pairs. Right, so there's one pair and there's a second pair. So what is this? This is a what? This is a parallelogram. This only has one pair of parallel sides. So this is a trapezoid. We got it? All right. We're going to get a little bit more specific about this in a minute, but let's label a couple things. You see the two parallel sides? We call those the bases. That's a base. And this is a base. In my honors class, we're actually doing area of stuff, okay? Triangles, rectangles, and even trapezoids, okay? Parallelograms. We're doing the area of that stuff. That's in chapter, 7 or something like that. And one of the things we have to know is that the parallel sides of a trapezoid are called the bases. Sometimes we'll call that base 1. Sometimes we'll call that base 2. Do they have to be the same, like in length? No, that one's definitely shorter than that one, correct? All right, that's why I called it base 1 and base 2. All right, so they're not necessarily the same. All right, we'll talk about that later. So those are called bases. What about the two sides that are not parallel to each other? We have a name for that. We've actually used this in the past. This is called the legs. Okay, that's one leg, and this is the other leg of the trapezoid. So the ones that are not parallel, we call those two the legs. The two that are parallel, we call the bases. You got it? So we got bases, we got legs. That's going to come in handy a little bit later. All right? So we're just learning words right now. Here's another word we're going to learn. Here's a specific type. Can somebody get the door, please? Here's a specific type of trapezoid. All right? So the other one was just an ordinary trapezoid. This one is, yes, sir.
Quick question.
Go ahead. No, it's perfectly fine. You guys are great. Thank you. Thank you. Let's do this. So I'm going to draw another trapezoid, but those legs, remember the legs, the non-parallel sides? There's going to be something that's true about those two legs. I'm eyeballing this a little bit, but I think that's pretty close. Now, I was trying to be kind of specific with this. What do you think I was trying to do to those two legs? Make them equal, exactly right, okay? So these are my parallel sides. What I was trying to do is to make this equal to this. Are those two sides always equal to each other on a trapezoid? No, because I drew one over here, right? That side right there definitely is longer than this side right here. Would you agree? That's still a trapezoid. But I specifically tried to make this trapezoid so these two sides were equal to each other. We have a name for that. And it's a name that we've learned before. When you had a triangle with two equal sides, what did we call that triangle? No, it's a triangle. A kite is 4 sides. Triangle, 3 sides. Nobody? A triangle with 2 equal sides? If I give you the first letter, you'll get it, but I want you to remember it. What is it? Make it, no. If 2 sides are equal on a triangle, I call that isosceles. You got it. Okay, so a trapezoid has a lot of similarities to a triangle. Even starts with the same letter, doesn't it? Right? Even the first 2 letters, TR. All right, trapezoid, triangle. There's a lot of similarities. Look, if I wanted to, a trapezoid, if I extended that and I extended this, what does it look like if they meet when they meet? Looks like a triangle, doesn't it? Okay, looks like a triangle, but I cut off top of the triangle. I cut it off parallel to the base. Everybody see that? So a triangle has bases, or has a base, all right? So does this. So we have an isosceles triangle, which means 2 of the sides are equal. What do you think we have here now? Isosceles. Isosceles what? What is this? This is not a kite. This is a trapezoid. Isosceles. Okay, it's isosceles, but this time it's a trapezoid. Okay? So what's an isosceles trapezoid? It's a trapezoid with 2 equal, what are these? These are what? These are legs, okay? So when the 2 legs are equal to each other, it's considered to be an isosceles trapezoid. We got it? Okay. So we learned what a regular trapezoid is. We learned what an isosceles trapezoid is. Let's do some examples. That's what everybody wants. That's what you came for today, right? get some examples? Yeah, because what do we care about? We care about quizzes and tests, don't we? We should care more about just learning the stuff, but you guys in high school, I get it. You just care about getting the problems right on a quiz or a test. So that's why we do these examples. All right, so I am gonna I'm just gonna draw this by hand. It might not be the prettiest thing in the world, but it'll get the job done. That looks pretty good, actually, doing that by hand. Zion. Oh. I thought you had some great point to make. I thought you had some insight you're going to give. But I should have known better, shouldn't I? Go to the bathroom. There you go. You're welcome. All right. What do you think this thing is? Well, I'll do this. Boom, boom. Don't say diamond. Don't you dare. Don't you dare. Have we ever mentioned a diamond in here? Never. Okay? What is this? A rhombus? What's a rhombus have? A rhombus has 4 equal sides. Look what I've done right here. Do those sides look equal? No. It's a quadrilateral. Okay? All these things in this chapter are quadrilaterals, but I heard it. Somebody said it. It's a kite. This is a kite because look, the 2 consecutive sides are equal. These 2 consecutive sides are equal. The opposite sides are not equal. All right, so it's a kite. So they are going to give you some measurements. This should not be very difficult for you. Well, it's stuff that we've done before. I'll at least say that. This is x plus 5, and this is 3x minus 1. What I want you to do is I want you to find the lengths. Find the lengths, or actually they don't say lengths. They say find the measure of the sides of this kite. Of the kite. All right, so they tell you it's a kite. All right, so that means that these 2 sides are equal and these 2 sides are equal. So how do I find the length? I want a number. Is it 17? Is it 12? Is it 10? What is it? What do we do? Let's think. This is stuff that we've done before. Okay, this is not new. What's true about these 2 sides? They're equal. So that's the length of this side. This is the length of this side. So what do we do with them? Say what? Find them? But in order to find them, what do we have to do with them? I add them? Make them what? Make them equal. That's right. Good job, Austin. So you make them equal to each other. So you set them equal. So watch what I'm going to do. So what's this side? It's 3 times y plus 2. You set it equal to what? 5y plus 2. Is this one up here equal to this one down here? No. All right, do you see it? Because you got these 2 tick marks right there. So these 2 are equal, and then guess what we're going to do next? We're going to set these 2 equal to each other. You got it? We're not going to add them. We're going to set them equal to each other. So what do we do here? Distribute. Very good. That's a good math word. Distribute the 3. So this is just algebra. Right here, we've done the geometry. Our geometry is basically over, okay? We just set them equal to each other. That's our geometry. Now we do some math, okay? We do some algebra. So what do we get here? 3y plus 6. We can't really distribute anything here, can we? So I go 5y plus 2. Let's get the y's on the same side. You could move the 5y to the left, but by doing that, you would have to subtract it. Then you go 3y minus 5y is negative 2y. Do you really want to work with a negative if you don't have to? No. So I would subtract a 3y and put it on the right side. Don't be afraid of putting the variable on the right side. All right, that cancels. Now, let's in the same step, we could bring everything down. I mean, we already canceled that. But what do we have to get rid of now? The y is on the right side, so what do I want to move over? The 2, right. I want to move that 2 from the right side and move it to the left side. How do I move that 2 over? That's right, I do the opposite, which is subtract. Subtract a 2 from here, subtract a 2 from here. Everybody see how we're doing that in the same step? Yeah, we've been doing that forever, ever since we've been doing these kind of problems towards the beginning of the year. Okay, that cancels. What do we get? 6 minus 2, 4 equals, yep, 5y minus 3y is 2y. Now it's super easy. What do we do? No, not subtract. This is being multiplied, so we divide. And so what's y? It's equal to 2. Is that my answer? Do I circle it? No, because they say find the what? The measure of the sides. So I could take that y, I could put it in for this one right here, or I could take that y, I could put it in for this one right here. It doesn't matter which one you do, because they're both equal to each other. Which one do you think is a little bit easier? Really, they're about the same, tell you the truth, but probably this one. All right, most people would probably think that was the easier one. Really, it doesn't make any difference. So put a 2 in for this. So let's just do it right here. So it's going to be 5 what? Times 2 plus 2. See what I did? I just filled in that y with a 2. 5 times 2 is 10 plus 2 is 12. So guess what the length of this side is? It's 12. Without doing any more math, what's the length of this side? It's also 12 because they're equal. Perfect. We've been doing this kind of thing almost since the beginning of this course, haven't we? Right? Set things equal to each other, solve for y, plug it back in. Yeah? Is that familiar to you? Should be. All right, because we've done it tons and tons of times. So that should not be all that difficult for you. So that's those two sides. Does that help you find these two? Not really. But what can we do? Do the same thing. Set them equal to each other, all right? So what I would do is I would take the bigger x, the 3x minus 1, and do that first, just so we can keep it on the left-hand side. So 3x minus 1 equals what? X plus 5. And now let's solve for x. I'm going to do it a little quicker this time. Subtract an x from both sides. That'll cancel. Add a 1 to both sides. This 1 will cancel. 3x minus x is 2x equals 5 plus 1 is 6. Divide both sides by 2. X is 3. It's not my answer, but I can plug it in and get an answer. Let's plug it into this one. This is probably the easiest one right there, isn't it? X plus 5. So I'm going to go what? Instead of x plus 5, I'm going to go 3 plus 5. 3 plus 5 is 8. So you got an 8 right there. So what's this side right here going to be? It's also going to be 8. Ben, you got a new seat. You're in that seat all the way in the back, 2 behind Austin. And there you go. Those are your answers, okay? 12 and 12, 8 and 8, and you're done. That's how you do it. That was pretty easy. You really didn't have to know much about a kite at all, did you? You just had to know that these two sides were equal and these two sides are equal. That's really the only geometry that you had to know there. I'm going to skip exam. Oh, my voice just cracked. I tell you what, I'm going to stop right there. Stop. Okay? Now, I don't know. I'm going to give you 1 to 18, but there may be some. Vinny, you watching? So here, I'm going to give you section 6.1a. This was on the lesson plan that I showed you before class. Well, before we started teaching. But it's also on facts, okay? Go to facts. It's on here, I believe. Let me just double check that I kept the same problems. I think I did. Let me flip to my lesson plans. 1 to 18, yep, that's right. So it's page 252. 1 to 18. I got like 2 minutes left. I want to look at the book just to make sure you can do all these. Because I haven't taught the whole entire lesson. All right, there's more to this lesson. This is what, chapter 6? Let me take a look. 1 to 18. Yeah, you probably, it looks like you won't be able to do all of them. So let's change it. Instead of 1 to 18, let's make it 1 to 13. Okay? Because 14 to 18 is the stuff we haven't taught yet today, but I'm going to teach it tomorrow. Okay? So 1 to 13, you should be able to do every single one of those. That's your homework. Okay? So make sure if you look on facts, it'll say 1 to 18, but I change it to 1 to 13. That's better than giving you more, isn't it? Of course, tomorrow's lesson, you're going to have more, though, than what it says. So that's how it goes.